do the other cards on this side. Okay, card number 7. Here is how Gabriel and Jamia transformed the graph of f of x to get g of x. First, they scaled f of x horizontally by a factor of 2. All right, we're not doing it. We're not doing this one because we didn't do horizontal reflections. So let's go to 8. The equation represents a transformation of f of x. Here it is. Describe the transformations. Okay, so now we need to look at this equation and see what has occurred, all right? Let's start piece by piece. Every person that you see other than f of x, everybody there is contributing some transformation to this potluck, okay? So that negative is on the outside of the parentheses. Therefore, that negative is a vertical reflection because negatives are reflections. So we have a vertical reflection. That 4 is on the outside of the parentheses. So he's a vertical, and because we're multiplying, that's a scale by a factor of 4. Now remember, numbers bigger than 1 mean that it's a stretch. Okay? And this guy, he's inside the parentheses with x, so he is a horizontal. And because it's addition subtraction, that's a translation, which means shift. Okay, now remember that x is a liar. You would think negative would be left. It's actually to the right 5. Okay, complete these tables so that f of x is even. Okay, you guys, I don't know how much practice we've had with this, but this is very important. Make sure you understand this. And then we want to make g of x be odd. Okay, so let's see. Remember that an even function is one where you flip it horizontally and it lands on itself. Fundamentally, like looking at a chart, what the heck does that mean? Here's what it means. It means if I take an x value like a 2, it will have the exact same y value as negative 2. So every opposite x value will have the same y value, all right? So 1, 3, negative 1, also 3. Negative 2, 4, 2, also 4, okay? Over here, let's make it odd, all right? It's the same table, but this time we want it to be odd. Remember that with odds, they're the ones from that whiteboard activity that we did, where you were like, well, the numbers aren't the same, but I can look at the opposite one and then make it negative, not positive, or positive, not negative, and then it's the same. So this is that. Let's say this is a 2. Whatever 2's y value is, negative 2 will have the opposite y values. So opposite x values have opposite y values. So 1, 3, negative 1, negative 3, okay? Negative 2, 4, 2, negative 4, okay? If it kept going and it gave us like 3, negative 8, then it would be negative 3, positive 8. Okay, so opposite x values, opposite y values. All right, so it's okay to turn a negative into a positive if you need the opposite. Okay. Here are the graphs of h and j. Describe a sequence of transformations that moves h onto j. So we want h to be the original and go to j. Well, first let's see if a scale has occurred. Let's go to the middle right here and see what it does in one step. In one step, my original goes up 1. So it grows 1. And the new one, in 1 step, goes down 1. So technically, it flips upside down, but it's not taller. It's the same. It grows 1, but just like -1. You could still do new divided by original if you want. You'll still get the a value of -1. So if you do new over original, you'll get -1 over 1, which is -1. And that would go... oh, actually, we're not doing equations. No scale has occurred. But yeah, this number would go right after the equal sign if we were doing an equation. And it would just be representing the vertical flip. Okay, so we don't have a scale, but we do have a vertical reflection. And then after I flip this guy vertically, 1, 2, 3, he'll go 1, 2, 3 this way. And now we just need him to get here. So he needs to go up 1, 2, 3, 4, over 1, 2, 3 to the left. So up 4, 3 left, which is a vertical translation and a horizontal translation. Okay. Write 2 different equations that transform f of x so that they go through these points. So I'm seeing that if I just flip, if I flip this guy upside down, this point will go here, and this point will go here, and then that point will go here, and I get that, and it will go through that. So 2 different equations. So f of x negative f of x. We just want to flip f of x over. So I don't know, we can call our new function g of x if you want to call it something. Negative f of x. Okay, then they want another equation. So then the second one I'm thinking of is to translate this one, to pick it up and move it down 1, 2, 3, 4, and over to the right 2 so that it lands here and goes perfectly through these points. So this point will come here, and then this point will come here. So that would be that g of x, or maybe that's a new function, h of x, that equals f of x to the right 2 and down 4. And last but not least, 2 different equations that make this guy go through those points. So flip him horizontally. If he flips horizontally and goes down 1, these 2 points will fall here. So I'm thinking to call this f of x equals g of negative x, horizontal reflection, and then down 1. Okay? Another one? They want another one. What else? We got options. I'm sure we do. What if we flip horizontally? Let's see what we get. We get this situation. And then if we take the horizontally flipped one, let's call this h of x equals... Oh no, sorry, I've been saying horizontal. This is vertical. Equals negative g of x. But then we would need this point to go 1, 2 to the left, so plus 2. And then 1... Oh no, just kidding. Just kidding. You guys, I'm sorry. Okay, here we go. I'm thinking to pick these 2 points up and move them so they land right here. That's what I'm trying to do, these 2. So I'm actually trying to get this point to go here. So I need them to go 1, 2, 3 to the left, plus 3. And 1, 2 up, plus 2. And that's another one. Maybe you came up with other ones. Doesn't mean you're wrong. Maybe even better ones than this, because I don't know. That seemed like a lot of transformations. Okay, you guys. I hope you get it. I hope it's sinking in.